Hello, this is Don Allen. I'm the Executive Director of the Steel Framing Industry Association. Welcome to our broadcast of the Steel Framing Industry Association 2024 Project Awards. Today we'll be looking at some beautiful, unique, and innovative designs and construction methods. I've had the opportunity to review all the entries, and frankly, there are many more projects that are award worthy, but only some are chosen. First, just a quick word about us. The Steel Framing Industry Association is dedicated to expanding the market for cold form steel in construction through programs and initiatives that promote the use of cold form steel framing as a sustainable and cost-effective solution, advocate the development and acceptance of favorable code provisions for cold form steel, educate members with reliable data and other critical information that is essential to effective business planning, and create a positive environment for innovation with steel framing and steel framing products. To do this, we have several programs. Our capstone program is the code compliance certification, which ensures that the materials that our contractors use, our manufacturers make, our architects and engineers specify, meet the requirements of the building code and are certified code compliant by SFIA unannounced inspections twice a year at our manufacturer members and contractor manufacturer members. We also have multiple technical resources, including white papers, tech notes, architectural notes. We're developing one right now on buying coils for cold form steel framing, and we have multiple projects and products already out there. We have webinars and educational seminars, presentations through the SFIA Learning Portal that are AIA Continuing Education certified. And we have sustainability documentation. We have architectural outreach. We have architectural templates for specifications and all kinds of products and projects that can help those of you in the steel framing community and ecosystem. We have our BuildSteel, which gives information about the steel framing industry. If you or your company would like to be featured in a BuildSteel article or a BuildSteel program, please send us your information. We love to get the word out, as I say, call it spreading the gospel on steel. And then we have the Cold Form Steel Engineers Institute, a relatively new addition to the SFIA family, but our engineering community is very important to how our products get designed and specified, and we'll hear more about that as we go through some of these industry project awards. So let's take a look at some of these project awards. These recognize excellence in the use of SFIA certified cold form steel products and demonstrate extraordinary ingenuity. This is our second year of doing this. Last year, I was part of the judging panel, and it was quite an experience seeing the myriad of projects that came in and the ways that people are using this steel framing in innovative and frankly pretty cool methods. So no longer a judge, I'm going to introduce the judging panel right now. First of all, Tim Blattner. Tim is a principal architect with Fitzgerald and Associates, has been working in the industry for decades out of the Chicago area. It was first brought to us by Bob Group, who runs our architectural program here at SFIA. Tim is the former director of the CSI, Construction Specification Institute, Chicago chapter. Our next panelist is Michael Whitaker. I first met Michael 30 years ago on a Habitat for Humanity job site in South Georgia, building a handful of steel framed homes around a bunch of other wood framed homes. And Michael is a self-proclaimed tool junkie, and he taught me some of the tips and tricks on how you use some of these tools when building with cold form steel. And also Dr. Ching Yu. Ching Yu is a PhD and a PE and a fellow of the ASCE Structural Engineering Institute, SEI. Ching also chairs the ASCE SEI Committee on Cold Form Steel Members and is a professor at the University of North Texas in Denton, Texas, and has quite a sizable lab where he tests a lot of these innovative products, and many of the shear walls and much of the shear wall data that have gone into the codes for lateral resistance have been done by either Qingyu or Renault Surrette out of California. So with these judges, we have 9 categories that we're going to announce winners in just a couple minutes here. First category is low rise, next is mid rise, next is high rise, then we have efficient use of cold form steel framing, conversion from another material, in this case wood, architectural design detail, sustainable project, unique use, and finally, non-load bearing interior build out. So those are our different areas. What I'll do is I'll go ahead and hide my camera here so we can focus on the projects at hand, and let's take a look at our winners. The first category is low-rise project, and our winner is Bloom Exhibit at the Children's Museum of Denver, submitted by South Valley Drywall, Travis Vapp. Other SFIA members involved include Clark Dietrich and Frontier Drywall Supply. So this was a unique installation. The museum's design team had a vision of a whimsical garden to provide an immersive space for little ones and newborns. In order to take the vision from rendering to reality, the construction team at South Valley Drywall leveraged the BIM model and used a robotic total station to lay out the multi-dimensional space, followed by prefabricating framing members to successfully build a multi-axis complex design. As you can see in this photograph, there are lots of curves and arches, and even the light fixtures have curves to them, as you can see in this ceiling detail here. The layout of the rooms are in a way that little children and infants and newborns and the caregivers that work with them can have fun and experience this space in a 3-dimensional immersive reality. So South Valley Drywall, the Bloom Exhibit at the Children's Museum of Denver. The next entry is a mid-rise project, and our winner in mid-rise is AdTech Engineers for the Fairfax Market Mixed Use in Cleveland, Ohio. This was submitted by Andrew Newland of AdTech, and other SFIA members involved in this construction were Howick Limited and Simpson Strong Tie Company, who provided some of the hold downs and connectors in the shear walls. The judges provided specific notes on this project, stating that this was an excellent construction photos, distinctive narrative for each aspect of the project, and they liked the way that they erected the building, the CFS staircase as they went up, so it could be used as they built the project, so they wouldn't have to use ladders and other vertical integration devices. It was an unusual use of open web steel joists for floors. It was open web truss systems that were made on some of the same machines that made the wall studs. So the Fairfax Market Mixed Use project is a 6-story building consisting of 1 floor of non-load bearing framing designed by others with post-stitch and concrete slabs and 5 stories of panelized cold form steel wall framing on top. Typical floor and roof framing were constructed with 16-inch deep CFS trusses consisting of standard shapes built with in-house roll forming machines. Using trusses allowed for CFS to achieve greater than typical spans while while utilizing a lighter material. Corridors were supported with standard 10-inch deep joists. The lateral force resisting system was a combination of concrete and masonry shear walls at elevator and stairwells, as well as numerous X-brace CFS walls. Cold form steel was also utilized to build stair framing. CFS comprised all components of the stair, from risers, steps, stringers, and landings. CFS was also used to support heavy loading from window washing anchors at the roof level. There were numerous issues which needed to be resolved during this project. Wall panels were a maximum of 12 feet long and 12 feet tall due to shipping constraints. This caused issues at the 6th floor to roof transition and limited the length of shear walls. At the roof transition, parapet framing had to be rigidly attached to the top of wall panels to achieve parapet heights. This was done using straps and proprietary clips. Additionally, at the roof, CFS roof joist framing was used to support window washing equipment anchors. These anchors required special detailing of the joist and wall members to support the heavy loads and moments induced by the loading requirements. This project originally was supposed to be wood frame. The design team worked up front with a panelizer to convert the wood framing to panelized cold form steel walls and CFS trusses. The use of panelized CFS framing and CFS trusses helped to increase the speed of construction while also eliminating the use of combustible materials. That was the Fairfax Market mixed use from Antec Engineers. Our next category is high-rise project, and the winner in the high-rise category is Alloy from Simcoe in Los Angeles, California, submitted by Zachary Peterson. The notes from the judges: this was an interesting use of non-load-bearing steel in the curved framing, and as you can see in this picture, up on the roof, there is not only curtain wall cold form steel, but also some load-bearing framing in the bulkhead area. And again, the highest wind load on the entire project is right up here in the roof where they've got these cantilevered parapets, so really heavy loading on this structure. The CFS products were a significant part of the exterior and interior build out on this project. This was design build that required development of structural and non-structural designs and shop drawings, which became a deferred submittal with the city of Los Angeles. The owner builder decided to value engineer various design elements, such as the asymmetrical columns, which were initially designed and poured in place concrete. The light steel framing design is expedited constructions, lightened the building load, and resulted in the architect's vision being developed more cost-effectively and expeditiously. The reduction of poured in place concrete also reduced construction time and improved project scheduling while keeping the project aligned with targeted budgets. The owner substituted a metal framed radius column design in lieu of the poured in place concrete curved columns. This resulted in cost and time savings to the project. The column conversion from concrete to cold form steel resulted in a lighter overall building due to this conversion. Unusual and unique shapes in both walls and ceilings provided challenges, but showed the diversity of cold form steel framing to build these complex structures. So the Alloy project from Simcoe, the winner in our high-rise category. The next category is efficient use of cold form steel framing, and the winner is the Wynkoop project by Simcoe in Denver, Colorado. This was submitted by Stephen Bradford of Select Prefab. Other SFIA member companies involved were the Steel Network and Salas O'Brien, a CFSEI member. The notes from the judges included: this project demonstrated maximizing strength and cutting down the thickness of the steel framing, providing a good example that can be applied to future projects, panelization, and the judges really liked the fact that there were lots of photos from different aspects of the construction, starting with the panelization all the way through to the completed structures. And they noted that this was one of the best submissions, which included the pictures, the write-up, and other aspects of following the instructions in the entry packet. So this project started out in the panelization shop. Here you can see the eaves being applied to the outside of the panels, the workers rasping, and included these panels being completely finished before they went up on the outside of the structure. So that that could be accomplished, so that these finished panels could be safely shipped to the site, they had special containers that allowed the panels to be shipped vertically. This project was originally designed by a different architecture firm and GC, but the owner sought out better value by utilizing prefabrication of the exterior envelope and designed by a CFSEI affiliated design team and prefab team. These panels were designed to conform to parameters of providing best value to the owners by stressing cost savings whenever allowable. The transportation and storage of the panels employed their custom manufactured trailer that allowed panels to be shipped vertically in an upright position where they could be installed immediately upon delivery to the site. The engineer provided design on how to best utilize panelization and lift the panels appropriately without damaging the finishes on the outside. According to the project narrative, quote, "We employed panelization and lifting layout that allowed lighter stud weight and less steel and no welding, using wider single-story panels instead of two-story tall 10-foot to 12-foot wide panels allowed maximized stud weight economy using 43 mil thickness for most wall framing. Tilting loads for two-story panels often create a requirement for heavier standard stud framing regardless of wind loading demands because of the stresses on the panels when lifting. CFS lifting clips were utilized for removing welded steel angles and bolts. Using a mid-slab joint remove requirements for a welded steel plate and pin connection, further economizing material and installation cost," end quote. And again, the panels going up on the side of the building and the details showing how the adjustable connections were made, allowing attachment to the slabs, even if the slab is slightly out, as concrete often is, before panels go into place. So our winner from this category is the WinCoop project from Simcoe. Our next category is conversion from another material. And as I alluded to earlier, the other material was not only wood, but also open web bar joists that were used in the roof of Wagner College locker rooms from AdTech engineers on Staten Island, New York, submitted by Andrew Newland. Other SFIA member companies involved were Super Stud Building Products and Simpson Strong Kai Company. Notes from the judges included good details and an interesting project, excellent photos, and close-up photos showing integrations of the entire project, and included design details in their submittals. They also liked the fact that finished photos were included with the project as well. Cold form steel was used throughout the entire project. Aside from a limited first floor walls and the foundation and limited structural steel framing, cold form steel was used as roof rafters, floor joists, and load-bearing walls. CFS X-brace walls were used as the primary lateral resisting system. 14-inch deep proprietary joist framing with large punch-outs were used for all floor joists and roof rafters to reduce overall building weight. The primary wall support system was 6-inch cold form steel wall framing at the first and second levels. Prior to receiving contract drawings, the drawings had been converted from load-bearing wood framing and bar joists. The use of proprietary joists with large punch-outs was able to lower the overall weight of the building. Due to the very long spans, the use of these materials aided in the maneuverability and handling during construction, with single joists being able to be lifted by individual workers or pairs of workers as they're set in place. There were some very high walls on the field side, and there's a large series of openings, so very small space for jam studs along that one sunny field-facing side. Also, the roof rafters had a long cantilever that had to extend out, and the manufacturer of the joist was able to adjust the punch-out locations so that no punch-outs were in place above the bearing locations, reducing the need for web stiffeners. And again, the double sloped roof with the cantilever ends extending out over the field in both directions, and the large windows with very little space for shear walls or jam studs in between those windows above the locker rooms in the weight room on the field side. So again, the winner in the substitution of materials award category is Wagner College locker rooms from AdTech engineers. Our next category is architectural design detail, and the winner in this category is 8th and Figueroa by the Raymond Group. 8th and Figueroa is in Los Angeles, California, and it was submitted by Kim Witten. And look at this beautiful staircase, and you think, my gosh, what is that made of? Is that precast concrete? No, that is cold form steel. So the judges noted that the staircase was a beautiful addition. The building was a beautiful building. but no one would have thought to use CFS for this before. The architect that designed this beautiful waterfall staircase is Price Architecture and Interiors, and this is how it was done. The steel framing two pieces were attached tapered with a piece of sheet steel on either side to form these columnar shapes on both sides of the stairwell. The building is a 42-story apartment building, and the contractor took on several engineered designs for both cold form framing and miscellaneous steel iron along the way, always ready to help problem solve. This included an 11th hour design for a fire-rated generator enclosure extension after an LA Fire Department review, which significantly aided the temporary certificate of occupancy process. Contractor contributed to planning and problem solving for a perimeter metal panel roof cornice extended around the entirety of level 43. The contractor was the GC's go-to trade partner, performing 17 different scopes, including less common ones such as intumescent fireproofing, furnishing and installing fire protection specialties, lockers, mailboxes, sound isolated, and acoustical ceilings. And they were performed with safety, problem solving, and quality in mind. Back to the staircase, looking more closely at the vertical supports at the outer edge of the staircase, you can see that there are metal plates that were bolted to the side of the studs right here in this area that curved over into the horizontal framing under the stairs, as well as these vertical posts that allowed the guardrail handrail loads, which induced a moment down here at the bottom, to be resisted by the attachment of these posts into the steel framing enclosed inside of these curved sections of the stairwell. So quite an innovative and complex design, which allowed this beautiful staircase to be put in place with these special architectural finishes. So notice the rib design that is not only on this wall above the staircase as it comes down in curves, but also in this section of the wall down below. So again, the 8th and Figueroa staircase detail from the Raymond Group is the winner of our architectural detail design. The next category is sustainable project, and our winner is Acrisure Arena from Clark Dietrich in Palm Desert, California, submitted by Jennifer Egger. This was a net zero carbon certified building by the International Living Institute. The building was wrapped in a blanket of 2.5-inch thick exterior insulation and finish systems, EIFS, foam to achieve a high R value and stabilize the arena's interior temperatures, reduce the use of HVAC, and help to keep the ice in the skating rink inside cold. The designer incorporated a weather and air barrier system behind the EIFS system. The project had challenges surrounding the excessive heat in the Coachella Valley area, with temperatures exceeding 100 degrees at many times, many hours of overtime to maintain the tight schedule. The dealer's scope of work was completed within 7 months, as well as 2 interior ice rinks to keep cold. With 20 executive suites and multiple private premium club spaces, the standards on the project were exceptionally high. On the interior portion of the project, there were multiple general contractors hired directly by the owner for tenant improvement work and concession build-outs. Working well alongside and together with these contractors was vital in getting all the information needed to avoid conflicts and deliver a quality project on time. Dealer installed and integrated finishes and wall assemblies with multiple bar and restaurants and jumbotrons were installed. The exterior of the arena was expedited to finish in time for hockey season, which led to considerable overtime hours coupled with the excessive heat, which required multiple breaks and water for the workers. At the main entrance, dealer installed a large tube steel trellis structure. Putting the trellis together within the exterior wall system was a difficult and elaborate task, but the contractors were up to the challenge. Again, our winner in this category is Acrisure Arena from Clark Dietrich. Our next category is unique use. And our winner is BJC Phase 3 Modular Package from TJ Weiss Contracting. This is submitted by Chris Sauer of TJ Weiss in St. Louis, Missouri. Other SFIA members involved included Negra Materials and Clark Dietrich. Since there were no framed floors in these modular bathroom pods, the ceiling provided the main support of the structure. Modular bathrooms were engineered to support their own weight with full tile during the hoisting process, where they're trying to organize 277 bathroom pods and 224 head walls for just-in-time delivery. Access for all trades had to be taken into consideration. Entire modular packages was built off-site so that all current on-site conditions had to be taken into consideration when delivering. Installers had to use the lowest profile carts to support the weight and avoid the previously installed overhead MEPs when sliding these modules in place in the existing building. All CFS was ordered to required lengths to minimize or eliminate field cutting. Walls and ceilings of modular bathrooms and head walls were built as panels on horizontal jig tables. Note from the contractor, quote, "Our quality was on point. We had minimal punch list items and none of those were CFS issues," end quote. All CFS walls were constructed in a horizontal jig table to ensure consistency from start to finish and mitigate injury. All walls and ceilings were hung while in jig table with custom CNC drywall pulled from model and then moved to pod assembly pile using heavy equipment. Engineering the CFS to be rigid enough to keep tile grout from cracking through hoisting process was imperative. The entire interior finish was tile. And of course, none of this is possible without a good team. These men can't be thanked enough. Also worth noting, the scope pulled 44,000 plus man hours off-site with 0 injuries. And just like topping out a building with structural steel, this was the last pod, so they attached a little tree to it, marked it as pod number 227, and took this congratulatory picture at the end. So our winner, TJ Weiss Contracting Incorporated, for BJC Phase 3 Modular Package. And then our final category is non-load-bearing interior build-out. And our winner in this category is AdTech Engineers with the Volkswagen headquarters in Reston, Virginia, submitted by Andrew Newland of AdTech. Other SFIA members involved in this was CJ Coakley Incorporated, L&W Supply, Clark Dietrich, and Simpson Strong Tie Company. This project was an interior renovation of a building from floors 14 through 20 of an existing 20-story structure. The various levels included many unique architectural features for which cold-formed steel was integral in accomplishing the design. The spaces include raised floors, stair plinths, clerestory supports, seating, and numerous different curved ceiling features. Different features were used throughout the space to create unique areas. This project was, excuse me. In this photo, you can see the raised floors. You can see the ceiling fit outs over the existing structures. You can see very edges, the furred out walls over the existing walls to create the unique shapes. The built-up floors had unusual curvatures to them that had to be laid out in advance. Dealing with existing construction always poses problems. When installing freestanding framing on existing post-tension slabs, this can make things even more difficult because of the limitations on fastening. Without existing structural drawings or the original concrete contractor on hand, the locations of post-tension cables is difficult to determine. This project had numerous glass clerestory partitions on top of freestanding CFS framing. The long runs and turns in the glass did not permit the installation of sills and jam studs. With the use of ground-penetrating radar, freestanding framing was able to be installed using proprietary rigid clips and anchors without the addition of structural steel or architectural modifications. Many of the architectural features are curved in various directions. The plinths and raised floors requiring tracks to be clipped and bent to create the curved feature. Specialized curvable track was also utilized to create curves. Similar details were used for portion of the ceiling where the ceiling curved in plane. In other areas, curved studs were required to achieve the architectural intent. Proprietary curved framing was also specified to accomplish the needed radii. Many, many of the unique shapes provided the aesthetics that Volkswagen was looking for their North American headquarters in Reston, Virginia, as submitted by AdTech engineers. So this concludes the awards. Congratulations to all of our award winners. The awards are now going to be announced on BuildSteel to the rest of the world, to the people that did not attend today. This page on BuildSteel is going live right now as I speak. And if you want to link it to your friends, or if you are a winner or know one of these award winners or want to share it on social media, go to www.buildsteel.org, and this will be the top article in the feed. If you are not already a subscriber to BuildSteel, once you go to buildsteel.org, you'll see the subscribe button in the upper right, and you can get every Tuesday morning delivered to your inbox the latest news and information about cold form steel projects, framing, architecture, and industry news and events. Speaking of events, we hope you've enjoyed today's presentation. The award submittal period for 2025 will start at the SFIA annual meeting in conjunction with Build 25, AWCI's convention and trade show in early April. So April 1st is the date of the SFIA annual meeting, which will be in Charlotte, North Carolina. Also, if you plan on attending AWCI's convention and trade show, the early bird deadline was just recently extended to this coming Monday, December 9th. Use the QR code on the screen to go to the registration page on the AWCI site. There's no charge for SFIA members to attend the SFIA annual meeting on April 1, but if you want to go on the trade show floor, see the SFIA booth and some of the other exhibitors that are SFIA and AWCI members, please go ahead and sign up. The early bird deadline ends on Monday. And again, December 9th is the date. So this concludes the 2024 Industry Project Awards winner ceremony. Thank you for attending, and visit us at www.steelframing.org for the Steel Framing Industry Association. I am Don Allen. We've also had online with me today Meredith Perez. Thank you to all the SFIA staff. We wish you a great day.